So when we look at IP version 6 and we look at the different types of addresses, we have here also three types. We have the unicast, the multicast, and the anycast. We do not have a broadcast, but we do have an anycast, which is not almost the same. A unicast address is where we send from 1 to 1. And there are different unicast addresses in IP version 6, and we will have a look at all of them. The first one is a global unicast, which is similar to the public IP version 4 address. It's globally unique and it's a routable address. It can be configured either statically or assigned dynamically. Then we have the link local address. It's used to communicate with other devices on the same local link. It's configured as a single link and it's not routable beyond the link. It's something that only applies to the LAN part of the router, for instance. Then we have the loopback, which is the same as the local host, which is the 127.0.0.1 in IP version 4. Here we set all zeros except the last bit. So it's : 1 is the loopback addresses. We can have an unspecific address, which is normally an address we only use to use as the source address. This is just all zeros, so just a colon will give us all zeros address. It cannot be assigned to an interface, but it's normally just can be used as a source address in some cases. We have a unique local address, which is the same as the private IP version 4 address. It's used for local addressing within a site or also within a limited number of sites. It starts with FC00 and goes to FDFF in the first part of the IP address. And then we have an IP version 4 embedded address, but that's not covered in this course. When we look at the link local address, is, as I said, something that is only valued in the local link, but it is something that we require to have. So what we do is that we set it up with the interface so that they all have a link local address. They start normally with FE0 or 80, and it's a range from that one, a range /10. So it can start from FE80 to FEBF. Then it is a link local address and it's only valid on the local link. So here, if I use the link local address, I can send something within my LAN here, but it will not be routed out to other devices. Then we have the global unicast address. As I said, that's equivalent to the public IP version 4 address. It's allocated by ICANN also to make sure that it's globally unique. And today we are only using the 3 first bits of the IP address for the global IP addresses. So it's set to 001/3. So in this case, the range of the first hextet is from 2000 or 2000 to 3FFF. Then it is a global unicast address. Yeah, we can also set out the global routing prefix. We can set it to or divide the prefix into 2 different parts. Normally we have the global routing prefix, and then we have the subnet ID, which is something that we can locally use to divide our network into smaller parts. So we have the possibility to divide it into subnet IDs as well. And then we have here 16 bits for the subnet ID. So altogether, these 2 are the same as the 64-bit prefix. And the last one here is for the interface. The subnet IDs is, as I said, what the organization can identify the different subnets within its site. So it's here it is 16 portions, 16 bits. Then we have the interface ID, which is the last 64 bits of the IP address. When we want to statically configure a global unicast IP address, well, then we'd use the command IPv6 address and then the IP address, and the /64 indicates the prefix, which is the network part of the IPv6 address. So we can just statically put it in. We can also do that in some kind of a Windows setup, so we can give the IPv6 address manually. Then there are different ways of assigning an IP address dynamically. There are the Stateless Address Auto-Configuration, or SLAAC. This means that the router itself uses the ICMP version 6 to send router advertisements, or RA messages, where they can send the prefix length, and the default gateway. Almost all that you need to be able to run on a device. So that it uses IPv6 to send this information. You enable that by using the IPv6 Unicast routing command to enable IPv6 routing. There are different variations of using SLAAC. You can use it as the only option, but normally you need to assign more than just a prefix and the prefix length and the default gateway. You need, for instance, also to assign the DNS server. And then you can either make the SLAAC cooperate with DHCP version 6, so that you can say that I'll give you the first information, and if you want DNS, for instance, then I will hand you over to the DHCP server in the network. Or you can make the DHCP server handle everything. The routers here will send the ICMP version 6 messages using the linked local addresses. So here, for instance, I can the router or here the computer will need an IP address, so it will send out to all IPv6 router, I need addressing information from the router. So then the router answer back. Here you have your prefix length, and gateway information. Or the other option is that it will then tell you, okay, to go to the IP version or the DHCP version 6 address for rest of information. Or the last option is to only use an IP version 6 DHCP address. Yeah, so the reason why in the first part here is we only need to hand out the prefix and the prefix length, because the host addresses can be put in automatically. The most the solution that are most widely used is to use the EUI64 process, where we actually use the MAC address, because we already have a unique address, which is the MAC address. That is 48 bits, so we can just use the 48-bit MAC address as the host address. So in this case, we just set that up, and there is this standard for that, which is called the EUI64 process, where you take the MAC address, split it in two, with each 24 bits. You flip the 1, 2, 3, 4, 5, 6 bit is flipped, and then you add between the two portions. You add FFFE. Because then you get altogether a unique 64-bit address. This is just, the rule that are set. To configure it, well, and you can see it here, because you can actually see here that it has these specific host numbers, which is made up by the IP or the MAC address. You can also make it just a randomly generated interface number. Vista was the one who began to do that instead of using the MAC address. Yeah. So the link local address is used to find the local router for the default gateway, and also the routers are using them to identify the next hop router between between the routers. So here we can also set it up dynamically so that we will just be given an IP address, or we can calculate it ourselves by using the EUI64 process. Configuring the local link or the link local, well then here we are using FE80 as the prefix, and then we just give it the first number 1. So here we actually, as you can see, all the 3 different interfaces here have the same link local address, and that's okay because they are only something that are used on each link, so it doesn't matter whether they are the same. Yeah. So here we have statically configured the 3 different link local addresses. And we can verify it by using the command show IPv6 interface brief. Then it will show us all the IPv6 IP addresses that we have configured. To see the routing table, we use the show IPv6 route command to see them. To assign different multicast addresses, well then we have different types of multicast addresses. We have the assigned multicast and the solicited node multicast. The first one is the FFO2 :A, which is all nodes multicast group, which is basically the same as a IPv4 broadcast address. All the IPv6 addresses on the network are joining this group automatically. Then there is the all routers multicast group. So if you enable IPv6 unicast routing in your router, well then it will also be joining this multicast group for all routers. Yeah, just an example here. The last thing, and it's a little bit complicated, or not really, but if you look at why and how it's created, it's a bit difficult. It's something called the solicited node IPv6 multicast address. This is just to make small multicast addresses where only one device is joining in. And this is to be used as the similar to ARP on IPv4 networks, so that if we have an IPv6 network and we want to actually send it locally, well then we can use these solicited node IPv6 multicast address to do so. And in this case we actually just set the first 104 bits to a specific bit pattern, and then we copy the last 24 bits. The last 24 bit is half of the MAC address, and normally it is only one that has this MAC address. So in this case we try to keep it local. So in case of sending something only to one, then we can use this address, because normally it will be only one in this multicast address. So it's instead of using ARP that we are using it. And that was it.